This is polynomial division part 2. We're dividing by linear binomials. We are dividing by linear binomials. So if you recall, linear means the exponent, the highest exponent is 1. Binomial means there's two terms. So that's it. And we're doing long division. So if you recall, when you had to do long division, let's say you had to do like 754, let's do 7,543 divided by 129, something like that. The long division look like this, 129 into 7543, right? That's what we're going to do. So it's something similar to that. All right, so we're going to put the x plus 4 outside of the box. X plus 4 outside the box, and what we're dividing into inside the box. So that's 7x cubed, right? All I'm doing is copying that. Make sure to put space up here because that's where the answer is going to go. All I'm doing is copying. All right, so I've copied the x plus 4, what I'm dividing by out here, and what I'm dividing into inside the box. Now, here's the next step. You're going to just compare the first term over here to the first term over here. So x times what is 7x cubed? All right, I'm going to use the, all right, so what does that mean? Okay, so you can think of it this way. You just did, or previous lessons had monomial division. So you can just do 7x cubed divided by x. That's 7x squared. So if you multiply x times 7x squared, you get 7x cubed, right? You add the exponents. So you can think of it this way to get what you need. So it's x times 7x squared that gives me 7x cubed. So whatever you put up here, and remember this is part of the answer, x times 7x squared, because remember, if you don't see an exponent, there's an invisible 1. So 2 plus 1 makes 3. So I'm going to now do 7x squared times x, which is 7x cubed. And if these two do not match, then something went awry, right? Now, what do I do with this 4? So you're going to take that 4 and multiply with what you put up here. So it's going to be 4 times 7x squared, which is 28x squared. Now, if you remember from long division, now we subtract. So these signs change. So the positive 7x cubed becomes negative 7x cubed. The positive 28x squared becomes negative 28x squared. And then combine. So these two cancel. The 7x cubes cancel. And then 29x squared minus 28x squared is 1x squared, or just x squared. All right, we have two terms over here. So I'm going to just bring down a term. So it's going to be plus 9x. Now, x, now you're comparing it to x squared. You're comparing the x to x squared. So x times what gives me x squared? Well, that's just going to be x, right? X times x is x squared. So x times x is x squared. And then, don't forget, I'm going to take that x and multiply it with the 4. So that's going to be plus 4x. And now I subtract. I change the sign. So I'm now doing 9x minus 4x, which is 5x. And then I bring down the plus 20. And then I compare. X times what gives me 5x? X times what gives me 5x? So it'll be times 5. So it's plus 5 up here. And I multiply that out. 5 times x is 5x. And then 5 times 4 is 20. So it's plus 20. And this time, when I change the signs and combine, negative, negative, they cancel. And this is my answer up here. That is my answer. That's it. Okay. Let's do the next example. Example B. All right, again, I'm just going to copy the x minus 7 out here. X minus 7. Draw my box. And I'm going to put the dividend, the long part here, inside the box. But there's a twist here. You will notice that I am missing an x to the 4th, right? It goes x to the fifth. It's missing the x to the fourth because x cubed, x squared, x to the first, no x. So 5, 3, 2, 1, none. So it's missing the x to the fourth. Now, it is not necessary to do what I'm about to do, but it keeps things organized. What am I going to do? I'm going to just simply put in a plus 0x to the fourth. Okay, this helps keep things organized. So remember, if I'm just adding 0, I haven't changed anything. I'm just changing the way it looks. All right, now I'll copy the rest. So it's minus 39x cubed minus 7x squared plus 5x minus 41. Ooh, I'm running out of space. All right. Now I compare x to x to the fifth. X times what gives me x to the fifth? Remember, this is x to the invisible 1. So 1 plus 4 makes 5, so I need x to the fourth. So when I do x times x to the fourth, I get x to the fifth. And I do negative 7, so don't forget the second term gets multiplied too. So negative 7 times x to the fourth is negative 7x to the fourth. Now I change the signs, so that's going to be negative and positive. So that's going to, 0 plus 7 makes 7, so 7x to the fourth. Bring down the next term. I'm bringing down the minus 39x cubed. So it's minus 39x cubed. All right, now compare x to 7x to the fourth. So to get from x to the fourth, I need x to the third, and I now have a 7 up here, so I need a 7 in front. It's a positive 7, so I put a 7x cubed, right? Remember, I needed a 7, so I put a 7, and x times x cubed is x to the fourth. So now I take this, what I put up here, and multiply with this binomial. So that's going to be 7x to the fourth, and 7x cubed times minus 7 is minus 49x cubed. All right, don't forget to change signs, right? If you realize it's subtraction, that's okay. I just find it easier to change the signs and combine, right? Positive 7, negative 7 cancel. I got negative 39, positive 49 makes positive 10x cubed. Bring down the next term, so it's minus 7x squared. Now, what is x times what is 10x cubed? X times what is 10x cubed? That's going to be 10x squared. 10x2. So I'm going to take this and multiply both of these over here by 10x squared. So that'll be 10x cubed minus 70x squared. And you will notice when I change signs and combine, everything cancels. So all that's gone. I'm not even bothered to write a 0. But I still need 2 terms, and I have 2 terms left. So what I'm going to do is just bring those down, both of them down. I'm going to bring both of them down because I need 2 terms. So that's going to be 5x minus 41. So so I'm still comparing x times what gives me 5x, right? X times what gives me 5x? Well, it'll just be 5. So I'll just put plus 5 up here. So it'll be 5 times x is 5x minus 5 times 7 is 35. Or 5 times negative 7 is negative 35. All right, change signs and combine. So 5x and negative 5x cancels, and that should happen. That's why we chose the number 5. And negative 41 plus 35 is negative 6. Now, I am done because there's no x's left over. There is no way to match another x, right? So that's it. That's it. So this is a remainder. The negative 6 is a remainder. And how we write the remainder in these problems is like this. You can write plus negative 6 over the divisor. Okay, you are welcome to write minus 6 over x minus 7, but this is just as okay, right? Plus a negative 6 over x minus 7. All right, that's example B. Let's do example C. All right, the difference between example B and example C is there is a leading coefficient on the divisor, okay? That's going to make things a little more interesting, but it's not that different. All right, so let's copy the problem. So it's 4x plus 2 divided into 12x to the fourth plus 6x cubed plus 12x plus 6. All right, all I did was copy the 4x plus 2 and copy the dividend. All right, Now compare 4x and 12x to the fourth. 4x times what gives me 12x to the fourth? Well, that will be 3x cubed. 4 times 3 is 12. X times x cubed is x to the fourth. So now take that and multiply with the both terms. So that'll be 12x to the fourth plus 6x cubed. And when I subtract, everything cancels again. All right, I still need two terms, so I'm just going to bring down those two terms. So 12x plus 6. And I compare again, 4x times what gives me 12x? Well, 4 times 3 gives me 12, so I just need 3. 3 times 4, x is 12x, and then 3 times 2 is 6. And when I change signs and subtract, everything cancels. So there is my answer. All right, just in case it wasn't clear, the answer was all this, the last problem. Okay, there am I. And that's the end of the video. Thanks for watching.